the future of electric cars has become even brighter. From the first electric car by German engineer Andreas Flocken in 1888 to what we have now, there has been serious evolution to electric vehicles. However, it is unfortunate that as of 2023, only 8% of vehicles sold in the United States are electric-powered. Most people refuse to make the jump because of the 600 km max range for most EV. But with the new electrolyte gel, people will see electric cars differently. And in this video, we'll show you why this gel will revolutionize the EV industry and talk about its structure. So, let's begin with the why. Number 1. Longer range. At a point in history, horses had more range than gasoline vehicles. For the average family, gasoline vehicles were way too expensive. Even if they could pull together the money to buy one, it was less useful than a horse was. Over time, engineers solved the problem of range for vehicles by significantly improving the size of the gas tank, among other things. This is what the electrolyte is doing for EV. This gel has the capacity of adding 400 km to the 600 km EV can travel for. This easily removes the fear of the battery dying off during a trip or the need to charge always. Number 2. Cheap. The research team at the Pohang University of Science and Technology has described this gel as cheap. To manufacture 10 EVs at the rate of $500, a gallon of the gel can be bought to service the 10 cars for $1,000. This adds about $100 to the production cost of the EV. This cost-effectiveness incentivizes every EV manufacturer to buy the gel and build better EV for the public. And by offering affordable performance improvements, EVs become more accessible to more users, accelerating the transition to an environmentally friendly transportation. Number 3. Lighter electric vehicles. Apart from distance, the reason for some people's refusal to transition to EV is because of the heaviness of EVs. This is because EV batteries are heavy, but that will soon no longer be the case. With this electrolyte gel, building an EV with the same range standard as the current electric vehicles, the manufacturer would need 40% less battery. This is because the gel can potentially trap more energy into each battery cell. This simply means lighter vehicles, but it doesn't stop at just lightness. There is serious improvement in efficiency, which potentially opens up design possibilities for sleeker, more aerodynamic models. Number 4. Faster charging. This gel promises a faster charging time with the added advantage of longer range. Usually the logic would have been more charging time to get more range. Now, with this gel that is not the case. The improved battery technology it provides paves the way for faster charging capabilities. This gel could lead to shorter charging times at stations, further reducing inconvenience and making EVs even more practical for daily use. Number 5. Eco-friendly. Being eco-friendly is the most important box every EV must tick in order even to be considered an EV. The electrolyte gel makes the global efforts to combat climate change much more feasible because it will increase EV adoption, thanks to improved range and affordability, which would in turn lead to significant reductions in greenhouse gas emissions and overall environmental impact. This is in line with efforts to fight climate change and build a better future. So, now you know why the gel will revolutionize the EV industry. Now let's talk about the how. Modern electric vehicles can cruise up to 700 kilometers on a single charge, but the quest for an even greater range continues. Researchers have long turned their attention to silicon, known for its high storage capacity, as the anode material in lithium-ion batteries for EVs. Researchers are pushing the boundaries, aiming for a groundbreaking 1,000-kilometer range, more than doubling current capabilities. However, despite the promises of the material, incorporating silicon into practical battery designs remains a complex challenge. It is no doubt a piece of welcoming news when Professor Sujin Park, PhD candidate Minjun Jae, and Dr. Hyebin Son from the Department of Chemistry at Pohang University of Science and Technology announced at the Consumer Electronics Show, CES, 2024, that they had made headway in solving this puzzle. Incorporating silicon into batteries introduces an obstacle as it undergoes a dramatic volume change during charges. Silicon exceeds 3 times its original size while absorbing lithium ions during charging, and then returns to its initial state upon discharge. This substantial expansion and contraction significantly destroys battery efficiency. To combat this effect, the research team at the Pohang University of Science and Technology employed an electron beam to form covalent linkages between microsilicon particles and gel electrolytes. The covalent linkage function disperses the internal stress caused by volume. expansion during lithium-ion battery operation, relieving the changes in microsilicon volume and enhancing the overall structural stability of the silicon battery. The head of the research team, Professor Soo-Jin Park, said about the achievement, "We used a microsilicon anode, yet we have a stable battery. This research brings us closer to a real high-energy density lithium-ion battery system." 1,000-kilometer range EVs. Part of the goal of this gel is to boost the range of EVs. 1,000-kilometer range electric vehicles are an important aspect of reducing our reliance on fossil fuels. Manufacturers have been trying to cross this threshold, but their endeavors have been futile, while others have built electric vehicles capable of the 1,000 kilometers mark. Car manufacturers like Toyota and NIO have claimed to have built EVs with a battery power range of 1,000 kilometers on a single charge. This comfortably puts them ahead of rival manufacturers like Tesla and Mercedes-Benz. When asked about the achievement, NIO CEO William Li said, "The completion of this endurance challenge proves the product power of the 150 kilowatt-per-hour ultra-long endurance battery pack." Li also added, "This battery is currently the battery pack with the highest energy density in mass production in the world and has excellent safety performance. More importantly, all models on sale can be flexibly upgraded to 150 kilowatt-per-hour batteries through the NIO battery swap system." The all-electric NIO ET7 is the only EV that has backed up at 1,000 kilometers range claim, as William Li during a live stream drove the all-electric ET7 vehicle for 1,044 kilometers on a single charge. Toyota plans to launch its Lexus LFZC concept car, which is designed to travel 1,000 kilometers on a single charge by 2026. EV has sure come a long way. Michael Faraday must be proud, because at the core of the creation of EV is Michael Faraday's work on electricity and magnetism. Faraday's work gave birth to the application of electricity into many ventures including vehicles. While sleek Teslas zooming down modern highways might seem like a novelty of the 21st century, the story of electric vehicles stretches back a surprising distance, weaving through a tapestry of innovations, setbacks, and renewed ambitions. The journey began in the 1800s, when the very idea of self-propelled carriages was taking its first tentative steps. Inventors like Robert Anderson in Scotland and Thomas Parker in England experimented with crude electric vehicles powered by batteries, some even achieving speeds of 6 miles per hour. Those early electric carriages, though charmingly clunky, offered a glimpse of a future free from the constraints of horses and fumes. As the 20th century dawned, electric vehicles experienced a golden age. Their quiet operation and ease of use found favor, particularly among women drivers. In the early 1900s, electric vehicles outnumbered some cities' gasoline-powered counterparts. However, challenges soon emerged. Batteries lacked gasoline's range and energy density, and the discovery of vast oil reserves made gasoline cheaper and more readily available. By the 1930s, the combined forces of affordability and range anxiety pushed electric vehicles off the road, relegating them to niche applications like industrial carts and golf buggies. The story doesn't end there. Concerns about air pollution and climate change in the latter half of the 20th century reignited interest in EVs. Pioneering models like the General Motors EV1 in the 1990s showcased the potential of cleaner transportation, though limited production and lack of infrastructure restricted their impact. The turn of the millennium marked a turning point. Advancements in battery technology, rising gasoline prices, and growing environmental awareness paved the way for a new generation of EVs. Toyota's Prius, launched in 1997, offered a practical and fuel-efficient hybrid option, introducing the technology to a wider audience. Tesla's Roadster, unveiled in 2008, showed the world that EVs could be both environmentally friendly and stylish. Today, the EV landscape is booming. Major manufacturers are investing in electric vehicles technology, offering a diverse range of cars, SUVs, and even trucks. Governments are introducing incentives and promoting charging infrastructure development. While challenges like range anxiety and charging times remain, innovation is accelerating. New battery technologies, like the recent gel electrolyte development, promise even more efficient and powerful vehicles. From the sputtering carriages of the 1800s to today's sleek models, electric vehicles have come a long way. This journey, marked by innovation, setbacks, and renewed ambition, reflects the ever-evolving quest for sustainable transportation. As we move forward, one thing is certain: the future of mobility will likely be electrified. carrying us towards a cleaner and more sustainable world. The future of transportation is electric. This is obvious to many people, but to many more, that future is bleak. A huge amount of people are yet to jump on the EV train, and range is a major excuse without them taking into account how far EVs have come. The development of the silicon electrolyte gel knocks out the range excuse and, in turn, improves the health of our planet. Do you think this new improvement will increase the use of EVs? Let us know in the comments, and don't forget to leave a like and subscribe to support our channel.